So we did one example. We'll just go over that. Okay. So 0.85 will be your p-value in the sense probability of success, right? Now remember, whenever you have these type of problems, you have to identify three things: n, p, and x. Okay, so you need all these three to calculate a binomial probability using a calculator. How do you do that in your calculator? You have to click on the second VARS, and then you can go to binomial PDF. Right? So you have the steps here. Second VARS, and you can click on the 0. So when you enter 0, you will be asked to enter these three values. You will find all these three values in the question. So this is what we did in our last class. So you have another example of similar kind. Now I want you to use your calculators and find the value. So what do we need? We need n, comma p, and x, right? N, p, and x. So what is n? 20. What is p? 0.67, the probability of success. What is x? 14. Okay. Now, how did I choose these values? N will be total number of anything. Could be in this case, in this example, it is number of devices. So, total number of devices. This is probability of success, or the probability given in your example. X is the selection. So how many are selected? 14. So my x is 14. So how do you do this in calculator? Second was then and DISTR, and then go to 0. Choose 0 here and enter. 0, enter. Binomial PDF. Now you have to enter n, p, x in the order. So n is what? In the example here, 20, comma 0.67, comma 14. And then you can close the parenthesis and enter. That will be your binomial probability. Okay, which is 0.1838. 0.1838. Answer must be 0.1838. So this is example 4 and example 5 in the same way. Okay. So in this, what is n? N is equal to 5. Yes. Probability is 0.6 and x is equal to, we have two options here. So here x is exactly 3. So you have n p x. So find out the answer. For B, they are saying the number of adults is at least 2. So that means x is greater than or equal to 2. So first find that and then I will tell you what to do. Done? This is binomial PDF of n, comma p, comma. What is the answer? 0.3456. Right. Okay. Now, when they ask you at least 2, that means minimum has to be 2, right? Minimum has to be 2. So minimum is 2 and we need to check the probability of at least 2 means greater than 2, right? Does that make sense? So as this symbol says that we need to find a probability for x values which is greater than or equal to 2. Do you remember in your lab 5 you did find the probability of few African Americans, right? 2 or fewer than 2. So that is what we are going to do now. So now let's divide in this table 1, 2, 3, 4, 5. Of course, we don't have to find for 0 and 1 because we need probability greater than 2 or equal to 2. So just let us fill this probabilities now. 0, 1, 2, 3, 4. Now, how do you find P of x? Very simple. You know what is n is equal to 5 and P is equal to 0.6. Find the binom PDF. Use your calculator and find for this. You just have to change the x values. Do this and tell me the answer. And so on. Remember, there is only change in the x values. Everything is going to be same. Done? Okay. 0.01024. I think I'm getting answers from Erica. So, and then, okay. Did you get the answer for next? How much is it? How much is it? What is the answer for x equal to 2? 0.2304 and 456. 0.2592. Okay, so we did find for rest of the x values. Now what we need is probability of x at least x equal to 2. So how do you find this? You just have to add the probabilities which are equal to 2 and greater than 2. Very simple. How much do you get? You just have to add the probabilities. 0.91216. Okay, 296. Okay. So this is how you find the probabilities for at least 2. So next is binomial distributions. Binomial distributions, mean and standard deviation. So this is just a formula. You can use these formulas to find mean, variance, standard deviation of binomial distribution. Now remember, these formulas vary depending on the type of distribution. Okay, so we did find formulas of mean, variance, standard deviations. For the formulas were different for the other distributions. I think it is in section 5.1. Okay. Now here I just want you to find what is n p x. Okay. What is n p x? What is n, what is p, and what is x? N equal to 12, p equal to 0.95, x equal to sorry? No, no, x is not given. Okay, so x is not given. Fine. Now, how do you find the mean? You just have to use the formula mu equal to n and p. Okay, mu equal to n into p. Now find the variance. Variance is sigma square equal to n p q. Now you must know how to find the q. What is the formula for q? 1 minus p. Okay. Now find the standard deviation. The formula is square root of n p q. So that depends on the problem given. So if that is a binomial distribution, or if you can see in the formula, there is only P and N given. So in that case, you can use the formulas related to that. Done? Any answers for me? You just have to multiply 12 and 0.95. 11.4, that's right. And next is 12.95. What is Q? 1 minus 0.95, 0.05. So you just have to multiply that, and your answer is 0.6. Okay. Now square root of 0.6 is, yeah, roughly close to 0.8. Now how do you find the expected value? Do you remember in the previous class I told you expected value is nothing but the mean, right? Expected value is nothing but mean, which you already determined, which is equal to 11.4 here. Mean is nothing but expected value. Use the range rule of thumb to find the minimum and maximum number. So what is the formula for range rule of thumb? Mu plus 2 sigma and mu minus 2 sigma. We know mu, we know sigma, so mu plus 2 sigma and mu minus 2 sigma. Plug in those values and find these two. This will be maximum because we have plus 2 there. Let me, this is minimum, this is maximum. You told me 13, right? The maximum is 13, minimum is 9.8. Okay, now answer this question. You don't have to calculate anything in the last example. You just have to answer, is 12 a usual or unusual number? What do you think it is? Usual? Usual? Why? Very good. It is because 9.8, 12 is between 9.8 and 13, so it is a usual number. Okay, so this completes your chapter 5. It's short. Now let us, so this is your new chapter 6, chapter 6. And one more thing, you will not be having any labs this week, right? That means you are supposed to go to class, but there will not be any new labs teaching this week. Okay, you must be knowing that. Lab 6 will not be taught this week, it will be done next week. So you're supposed to go to the lab only if you have any questions, or if you are just struggling between the assignments 1 and 5. Okay, if you have not done any assignments, you can still submit. So make use of this opportunity. Test 2. We are still discussing the dates. I'll let you know. Going to chapter 6. Before I do this, So for the students in WebEx, um there is a Z tables available in your Blackboard. I'm not sure whether you can find it, but still do not worry. I will try to share that screen. Okay, so let's start. It is chapter 6. Standard normal distribution. 1. Now, you all know what is normal distribution, right? So the bell-shaped curve. So why do we want our variables to be normally distributed always? It is because in normal distribution, the mean, median, mode are all equal. Okay, and that is why we always want our variables to be normally distributed. Now, these are some examples. A picture of normal distribution. Now, this is a random sample of 100 women. Okay, some example, some random example. Now, they are going to increase the sample size, increase the number of people or the sample size, and likewise, the class width will be decreased. The width here will be decreased. Width is decreasing, the sample is increasing, so the height or the spread is increasing. Okay, so in the same way, if you can see the option C, sample size is further increased and class width is further decreased. Now, if you join all this, these corner points here, you get this curve, which is a normal distribution. Okay, so the most of your continuous variables, the variables which are continuous, will have this kind of nature. Continuous variables will have normal distribution kind of nature. Okay, so this is just a revision. Now, definition. A normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. So what do I mean by symmetric? That means when you draw a line in the middle, you can see that the shape of on either side of the line is same. So when the shape is same on both the sides, we call that as symmetric. Okay, so a normal distribution is a continuous, symmetric, and a bell-shaped distribution. Okay, very simple. Now, we will learn about some properties of normal distribution. Now, we know that it is a bell-shaped. We know that mean, median, mode are always equal, and it is unimodal. What do I mean by unimodal? That means it will have only one mode. Unimodal. Okay, so for example, if you have some sample size 2, 3, 4, what is the mode of this data set? 2. So what is mode actually? A number which is repeated most number of times. So in this case it is 2. So we have only one mode, and this is called as unimodal. So they say that in a normal distribution, always we have only one mode. There is only one mode, unimodal. Now, the curve is symmetric. We studied about that. A curve is continuous. That means there are no gaps or holes. So if you can see this picture here, you can see there is no gap or a hole in the curve. Okay, so it is continuous and symmetric because it is equal on either side of the graph. Now, the very interesting property is this: the curve never touches the x-axis, right? So you have seen many normal distribution graphs. You would have done this in your lab. When you plot a histogram, below that, you can see a bell-shaped curve. So any normal distribution, you will not see this type of normal distribution. Okay, this is X line. It will never touch the X line. Okay, so this is one special property of normal distribution. Now, total area under a normal distribution will be equal to 1 or 100%. It will be equal to 1 or 100%. Okay, and we also know about this empirical rule, right? If it is within one standard deviation, it is 68%. Two standard deviation, it is 95%. Three standard deviation, it is 99.7%. We studied about this in the previous chapters. So these are some properties of normal distribution. Okay. Now, we studied about normal distribution. Then what is a standard normal distribution? It is the same thing. It has the same properties and same definition, but if the mean is 0 and the standard deviation is 1, if the mean is 0 and the standard deviation is 1, then that type of normal distribution is called as standard normal distribution. Looks like this. Okay, here you can see it is just a numbers. So in a proper normal distribution, you will be having something like this, right? Or mu plus sigma, mu plus 2 sigma, likewise. So in case of standard normal distribution, you will not have that terms or that formula. You will have the actual numbers. That's the only difference between normal distribution and standard distribution. So in standard normal distribution, the mean always has to be 0. Standard deviation has to be 1. This is one of your homework questions. Okay, remember that. Okay, so in normal distribution, this is a formula. You don't have to remember this. So just just know this, that for a normal distribution, we use X score. We are not studying about this in this chapters, okay? But for a standard normal distribution, we use Z score. Okay, that's what I gave you just now. So that table which I gave you is a Z score for a variety of areas. Okay, now remember, we know that mu equal to 0, sigma is always equal to 1, and area, the total area under this curve, it will always be 1 or 100%. Keep remembering these values. It is very useful. Now, comparison between normal distribution. You can easily read this. It is a bell-shaped, both are bell-shaped. Mean can be anything, but in standard it is 0. ST can be anything, which is standard deviation. Here it has to be 1. So there we use X score. Here we use Z score. Okay. Okay, so let's straight go to the example. Now, uniform distribution. It is nothing but a type of normal distribution, whereas here only difference is the values are spread evenly, which means, so this is our normal distribution, right? Now, if you can see the data values, these are the data values which are increasing to one point and they are decreasing, increasing, decreasing. But what they are saying in uniform distribution is that these data points should not increase nor decrease, they have to be equal. It has to be a horizontal line or a vertical line. Horizontal line or a vertical line. Which shape is this? Rectangle. So uniform distribution must always have a rectangle shape. Normal distribution will have a bell shape, whereas uniform distribution will have a rectangle shape. Okay? Okay, so we will do example 1. Given that it is a uniform distribution, we need to find a probability. So here, probability is nothing but the area. Okay, area. Probability is nothing but the area. So we need to find an area of two things, greater than 124 and less than 123, and between these two values. Okay, before you do anything, so you have, I guess you have 3 of these questions in your homework, I mean MLM. Okay, so before you do anything, you have to write or draw a figure. This is x, this is probability of x, or the area. Okay, now this is 0 value. Now what they are saying is, so it is greater than 124, less is 123. So I will start from 123. I will go to 124, 125. 125 is the highest score. So let me do, this is just a random figure. You can plot anything you want. So, but it has to include the numbers which is mentioned in your question. 124.5, 125. Okay. So if you can join these values. Now I do not know what the height is. I just took a random height. Okay. I do not know the height. Fine. Now this is a rectangle. What is the area of a rectangle? It is width into height. Width into height. So this is width. This is height. The width on the bottom line, the width on the top line will always be equal. The height on opposite sides will be equal. That is the property of rectangle. Now, area. What do you think the value of area will be? It is equal to 1. Why? Because I told you the total area for uniform distribution will be 1. Okay, area is equal to 1. Now, how do you calculate the width? Very simple. 125 minus 123. So if I subtract these two, the minimum and maximum, I will get the width of the rectangle into height. I do not know what the height is, right? So this is what I want to calculate. Height of this big rectangle. What is the height? Half, which is 0.5. Okay. Now I will mark this half here. Fine. Now what should I find? I know what is height, what is width. I know the total area. Now they're asking us to find 3 things, that when the height is, or the x is greater than 124.5. So 124.5, 124.5 to 125. So this area, I need to find the area of this portion. Now, height is what? 0.5, right? What is width? No. Good. It is 125 minus 124.5, which is 0.5. How do you calculate the area? Width into height, which is 0.5 times 0.5. That gives you the area of that portion. Now calculate in the same way, you have to calculate the area for x, what is b, less than 123.5, less than 123.5. So this is A. This area you have to calculate. Okay, so this is B. Tell me the answer. Who said that? Yes. Did you get this answer? The answer must be 0.25. Did you get that? Okay. So h is equal to 0.5. Width is 123.5 minus 123, which is 0.5. Right? Now area is just multiplying W and H, which gives you 0.25. Okay, B is done. Now C. Find the area between 123.5 and 125. So you need to find this area. The area between 123.5 to 125. So this is C. Okay, area between, let me write this here. Probability or the area between 123 and 125. 23.5. Okay, find out the width, which is 125 minus 123.5, and height will be equal to 0.5. What is the area? Correct. So this is 1 point. Answer will be 0.75. Okay, so this is how you have to calculate the areas. Now you will have different questions with the same concept. Okay, you will not be finding only the areas, you will be finding number of other things. Okay, so we will do these examples also. Okay, now always draw the picture. Now it is from 0 to 6, right? The waiting time is between 0 and 6. Okay, now what do we have to find? We need to find the probability or the area greater than 2.25. We need to find the probability for x value greater than p of x greater than 2.25. Now, you don't have to divide the x line. You can just write 2.25 somewhere between those two values. Okay. Now, I don't know what is the height. I'll just draw a line there. So always you need to find the height if it is not given. Okay. Now, before I find this, I need to find height of a rectangle. A is equal to width into height. Now, total area is always equal to 1. For all the examples, what is width? 6. 0 minus 6, sorry, 6 minus 0. That gives you the width of the rectangle, which is 6. Height, I don't know. So height will be equal to 1 over 6. So I will mark the height on the rectangle there. Height is equal to 1 over x. So this is just to find a total area or the height. Okay. Now, the actual question, find the probability of x greater than 2.25. So you need to find the probability in this area. When it says greater, you have to move it to this side. Greater than, greater. Okay. So how do you find this? You just have to find the width and height. Height is equal to 1 over 6. Width will be 6 minus 2.25. That is 3.75. Now, what is the area? Width into height. 3.75 into 1 over 6 is 0.625. Okay. Now you have a same question in your MLM. Only difference is in this values. Same question. Okay. One of your homework question. Now I want you to answer this. Example 2. Calculate the probability between 50.25 and 50.75 and give me the answer. Always draw the rectangle first and then find the width, height, total area, and then you have to find the probability of its. Point 0.05. Answer will be 0.05. Okay, so next what we have is z-score. Do not forget to bring that paper to the next class. Okay, it is very useful and we need that paper to do these problems. Okay, so we will meet on